Hi there, my name is Hunter Bate. As a member of Team 2, today we are proud to present to you our final oral report on our topic, the feasibility of 3D printed bus components with various materials. Today, you'll be hearing from Raymond, our technical coordinator, myself, the team administrator, you'll hear from Aiden, our team coordinator, you'll hear from Janice, our document coordinator, and you'll hear from Ty, our graphics coordinator.
The first topic that will be covered in our oral report is 3D machines by Raymond. Next, Hunter will cover 3D printing materials compatible with use for mechanical automotive components, followed by Aiden presenting on the safety and reliability of 3D printing components, followed by Janice presenting about the feasibility of 3D printing methods and engineering applications. Lastly, Ty, will cover costs related to manufacturing mechanical parts. The order of the members presenting and what topics they are covering is also listed in your brochure under the title of presenting order. Thank you.
Hello, my name is Aiden. I am the team coordinator for Team 2, and for our report we will be discussing the feasibility of 3D printed bus components using various materials. The purpose of our report is to look at the problems existing in manufacturing today, such as component defects and cost, and propose the idea that 3D printing is potentially a very valuable manufacturing method. Since our OPR, one way we've deviated from our initial plan is by adjusting our scope and narrowing it from all vehicles to buses. This allows us to narrow our research and provide much more valuable content.
Everyone, my name is Janice Alderson, and I will be discussing the team's focus and main points that are covered on the report. So the team's main purpose is to determine the feasibility of automotive manufacturing using 3D printers. So 3D printing is commonly known as additive manufacturing in the industry. So as a team, we have decided to apply 3D printing technology on manufacturing components of a transit bus, specifically the autobody. So 3D printing autobody will provide benefits including improvements on the overall weight and the cost of manufacturing a bus. The main points that are covered on the report are the existing modern 3D technology, the materials that are used in 3D printers, the reliability and safety factors of the components to minimize failure, autobody application, methods of 3D printing, and finally, the report will cover the cost of implementing additive manufacturing.
Hello, my name is Raymond Gunawan and I am the technical coordinator for Team 2, and my section of the final report is 3D machines. I will be talking about current applications of 3D printing and the printer's capabilities in this current age. I will be discussing these to give an introduction of how 3D printing is feasible. I will start with the medical industry. The medical industry has been using 3D printing to manufacture drugs, organs, models for visualization for education, and prosthetic limbs. In the slides, there is a picture, an example of how 3D printing of a prosthetic limb that is manufactured with 3D printing. Next is the food industry. The food industry has been using 3D printing to make customized foods for children, athletes, and pregnant women who need special dietary needs and needs different nutrients. 3D printing can also be used to make foods faster and more efficiently. And food made by 3D printing looks better. In the slides, there is a picture of a food made by 3D printing, and it looks better than normal food. Moving on to the aerospace industry. The aerospace industry have been using 3D printing to manufacture spare parts for components that are easily damaged and needs constant replacements, like the engine. Not only that, it helps manufacture lighter components in commercial airliners. Finally, in the automotive industry, 3D printing can be used to manufacture lighter and more complex parts. Companies have been using this technology to make spare parts. In the slides, there is a picture of some parts that can be made with 3D printing. It is mainly used to manufacture the small parts like the gears. Next is printers' capabilities of the current age. This section we'll show that there are machines that can be used in the manufacturing level. One of them is the EOS M290, the white machine on the right. This is a 3D printer made by a company called EOS, who are specialized in 3D printing, and they have 6 different machines to perform metal 3D printing. This machine, the EOS M290, uses direct metal laser sintering to perform 3D printing, and it is highly productive for high performance parts. It is a small machine, so it is used for smaller components. The next machine, the blue machine, the one on the left, is the Matsuura Lumex. And this machine combines the flexibility of laser sintering and the traditional milling, which gives precision. This gives the part a better finish. This machine is bigger compared to the EOS M290, and therefore it is used to make bigger parts. To sum up, 3D printing has been implemented today, and there are machines that can be used to perform 3D printing in the manufacturing level. They are efficient and they are reliable. But this will be discussed in the other sessions. Thank you.
Hi, so let's talk about my section of the report, which is on materials that are compatible with 3D printing. So, my portion of the project is important because it sets a foundation for the rest of our report. It's important to know what materials we can actually 3D print with without major defects and deformations, as this will truly affect the strength of our parts that we make. So, as we can see in my first slide, it's a little bit hard to see in this video, so I'll direct you towards our slides online. You can see in the left photo here some air bubbles occurring from the 3D printing process. This is common to all types of materials that we 3D print, whether it be plastic, steel, or aluminum. Then one photo to the right from that, we see microscopic cracks that form in our 3D printed metal parts. More specifically, this can still occur in our plastic parts, but it's more of an issue in metallic manufacturing via 3D printing. So as we can see, there are some major defects that can occur from 3D printing that really limit the pool of potential candidates that we can use for 3D printing. In general, there's only about 50 of a possible 5,500 materials that are actually used in industry that also cross over with physically being able to be 3D printed. So because of that, I limited my research to 3 subgroups, being steel, aluminum, and plastic. And within that, I chose 1 or 2 front runners that have already seen success being 3D printed, and I looked at them to see if they'd be applicable for automotive applications. So starting with steel, I focused on one grade of steel called stainless steel 316L, which has some prior use in the medical field, has been 3D printed for medical applications. So it has prior success being 3D printed is what I'm trying to get at. I found in general that it tends to be less ductile than it needs to be, which is a bit of a problem when we talk about steel, making it essentially unusable, and I wouldn't recommend using it yet. Industry is still advancing on the front of 3D printing, so I'm sure we'll get there at some point, but as of right now, I would say steel is not a viable material to 3D print for bus components. The next thing I looked at was aluminum alloys, which I do believe are viable for being 3D printed. I looked at 2 different alloys, the first one being a silicone and aluminum blend, and the second one being a nickel and aluminum blend called Inconel 718, which is what I'll call it for the rest of the video. The silicone aluminum blend, along with the Inconel 718, is pretty easy to 3D print, which makes it very viable in my opinion for 3D printing. It doesn't have a lot of defects or warping when it comes out of the 3D printing process, and in general, industry is moving away from steel and towards aluminum for parts. If we also include the fact that Inconel 718 is very good with its heat resistance and has prior use and applications in 3D printing specific parts of heat engines in the aerospace community. I would say this is definitely a good option to have under our belt when talking about automotive applications. And then finally, I looked at some plastic polymers. Now, plastic isn't used a lot in industry currently. However, I noted there was some good plastic polymers that really should perhaps be considered when we talk about creating automotive components. In my paper, I talk about, or in my section of the report, pardon, I talk about two polymers being polyamide 11 and polyamide 12. They have different characteristics, which is good because we might need it for plastic for different parts of our vehicle. Polyamide 11 is a bit more flexible and polyamide 12 is a bit more rigid with better heat resistance. So in general, since these are easy to print materials, plastic has lots of grounding in the 3D printing community already. I believe that steel is not quite there yet, but aluminum and plastic alloys definitely have a place in the 3D printing community and are viable as materials for 3D printing automotive components. I'll pass it on to whoever's next.
Hi, I will be discussing the safety and reliability of various 3D printed components. So before we look at the safety and reliability of a 3D printed component, we have to look at three factors. First of all, we have to look at the material characteristics itself. Second of all, we have to look at the overall quality of the print based on the printing method. And third, we have to look at the actual consistency of the print method. So for my report, I chose to talk about three different materials. I chose to talk about aluminum alloys, nickel alloys, and finally plastics. The reason I didn't address steels is because they're not as readily available using existing print methods as these other materials are. So first of all, we look at aluminum alloys. Why are aluminum alloys valuable? Well, aluminum is incredibly versatile given its lightweight and its malleability, making it desirable for numerous vehicle components. Now, when we look at aluminum, we see that a potential 3D printable alloy is an aluminum silicone alloy that can be seen addressed in my report. Studies have been done showing that this alloy can withstand several tests after being printed, and one possible defect can be seen in the image shown on my presentation slides, where cracks and errors can occur. Now, this specific instance involves a human error. After it was printed, it had undergone a polishing and sanding process, which resulted in these cracks. So this shows that the printing process is not the weak point, and that these materials have the potential to be very safe and reliable in vehicles. Now, moving forward, for nickel alloys, I chose to talk about Inconel 718. This material is incredibly strong and corrosion resistant, making it incredibly desirable. It's also currently being used in aerospace projects, proving that it can be safe and reliable. But the problem is that the material that's currently being used is incredibly expensive to manufacture, given its incredible hardness, meaning that 3D printing will eliminate this cost, making it much more readily available and even more valuable. Finally, I talk about in my report plastics. Now, plastics are obviously weaker than metals. This means that they tend to be used for gauges, dials, and switches in vehicles, more on the internal aspect of things, interior. And this means that safety is not as much of an issue as it is consistency in print. And so, as common as plastic printing is, it has the potential to be incredibly consistent, and it has been shown to be incredibly consistent, more so than manufacturing by hand or other plastic manufacturing methods. This means that it has the potential to be safe, reliable, and valuable. Now, finally, to conclude my report, or my section of the report, these materials that I listed are incredibly valuable as they do have the potential to be printed now, and they are proven to be safe and reliable. Thank you.
So in the final report, I myself is responsible for determining the application and the 3D printing methods. So in order to show the feasibility of additive manufacturing, it will be focused on applying it on manufacturing auto bodies of a transit bus. So the general steps are required to produce an application using additive manufacturing are: the computer-aided design, also known as the CAD model. Then that will be converted into standard triangle language, known as the STL file. Then the STL file is then entered into the 3D printer system. And then the required parameters are then entered. Once that's done, 3D printer then starts to print the model. Once the material is printed, then excessive materials are removed. The design is then processed. So there are many advantages of additive manufacturing that it has over the existing manufacturing process that are currently being used in the industry. So additive manufacturing produces a more accurate design, reduces the nominal weight of the product, therefore resulting in lighter components, which also provide better fuel efficiency and reduces the negative impact on the pollution. So it also improves the cost efficiency for company and the consumers, and also reduces the material waste. So additive manufacturing can also provide a faster manufacturing process. Most current manufacturing process requires multiple steps between the designing and the manufacturing process. Additive manufacturing can eliminate some of these steps, especially since additive manufacturing can produce a single component design rather than multiple components that requires assembly. So the second part of my section is the variation of the methods to develop a design. There are three primary methods that will be mentioned, such as the laser-induced forward transfer, the fused deposition modeling, and the selective laser sintering. So the laser-induced forward transfer is a direct method of additive manufacturing that allows for 3D printing different types of materials. The machine is able to produce design at larger scope. Therefore, this method could be applied to 3D printing auto bodies of buses. However, the method contains a flaw. When it comes to 3D printing process, which is the material are dispersed into droplets, causing adhesion complications. So the second method is fused deposition modeling, which is one of the most common and reliable 3D printing method. This method has a simple mechanism that allows for easy use, able to print materials such as polymers and composites in a short amount of time, and also produces high resistance to compressive force components, which is an important property for an auto body. So the main disadvantage of this method is that it has limited material capacity. So the last and final method is the selective laser sintering, which is commonly used in 3D printing strong and reliable components. So selective laser sintering uses a powder-based material to create a 3D design. Selective laser sintering is widely used in additive manufacturing due to its flexibility of material use. Thank you.
Hi, my name is Kaisal Fuchuk and I'm the graphics coordinator for Team 2. For my section of the final report, I examine the costs related to manufacturing mechanical parts. More specifically, I examine the costs associated with current mass manufacturing methods, and I compare these costs with 3D printing and examine ways to reduce the costs associated with 3D printing. Vehicle manufacturers need a way to mass produce thousands to millions of the same identical part. One way to do this is called ejection molding. Ejection molding is the process of creating parts by ejecting molten material into a mold. Once ejected, the molten material takes the shape of the mold and is cooled as a solid part. Manufacturing methods such as ejection molding have a high initial cost. This is because ejection molding requires expensive molds, tools, and forms. Similarly, with 3D printing, there is a high initial cost. The high initial cost with 3D printing is buying the 3D printer itself. Deciding if 3D printing is the better economical choice largely depends on the quantity of products being produced. As the volume of products increases, the cost per unit with ejection molding decreases. However, the cost per unit with 3D printing does not change. An example that demonstrates this is shown in the PowerPoint in Figure 1. As of right now, the better economical choice for mass producing parts in the thousands and millions is still ejection molding. The next section I will be looking at is the cost of 3D printers. The price of a printer can vary from $200 to as much as $100,000. As the features and capabilities of 3D printers increase, so does the cost. As technology advances, the price for these high-tech printers will become more affordable. In the last several years, the price of a 3D printer has significantly decreased. A 3D printer that would have cost $1,000 in 2016 now only costs $100. Once the price of 3D printers become realistic for mass manufacturers, the benefits that will come with that could revolutionize this industry. 3D printing could become a common approach for producing highly complex customizable parts, such as engine parts in the automotive industry. The market for these complex customizable parts has grown at an extremely high rate. It's predicted that by 2025, this market could grow to up to $770 billion annually. By this time, it's projected that 30 to 50% of these parts could be produced using 3D printers. 3D printing will be used so much more because the cost of these complex parts could be reduced by 40 to 55% due to the elimination of expensive tools, expensive molds, the reduction in wasted materials, and a reduction in the labor cost. It's only a matter of time before 3D printing will revolutionize the mass manufacturing industry. The final section I examined was the cost related to 3D printable materials. One of the current issues with 3D printing is the limited materials and the high costs that are associated. Manufacturing methods such as injection molding have nearly no constraints as to what materials can be used. The difference with 3D printing is that there isn't that wide variety of materials. The limitation of materials contributes to the high costs. Materials used in 3D printers can run 10 to 100 times more than typical injection molding materials. Despite these high costs, there are still benefits that will come with 3D printable materials. For example, 3D printing mechanical parts could reduce the amount of raw materials wasted by up to 40%. In addition, 3D printers can reuse 95 to 98% of materials that are wasted from traditional manufacturing methods. As has been shown, the benefits that come with 3D printing will be revolutionary. However, as of right now, the technology is too new. 3D printers do have the capability to be more cost effective. This technology is growing and expanding at an extremely high rate, and it is only a matter of time before most, if not all, mechanical parts are produced using 3D printers. Thank you for your time.
This concludes our report on the feasibility of 3D printing bus components with various materials. Public transport is an important part of the city's infrastructure, and the purpose of this final report is to determine whether or not 3D printing bus components is a viable economic option. This report focuses on current technologies in the current industry and limits to only using one material at a time. I have discussed the current applications of 3D printing. Hunter discussed the current materials capable of being 3D printed. Aiden discussed safety and reliability of materials capable of being 3D printed. Janus discussed different methods and possible applications of each method in regards to 3D printing bus components. And Ty discussed costs associated with 3D printing compared to traditional methods. The team has showed the current state of the 3D printing world and has determined that it is possible to 3D print bus components. Materials were also analyzed, and it is proven that there are materials that can be 3D printed. However, after an analysis of different methods, combined with a cost analysis of using 3D printing to make bus components, the team came to a conclusion that currently it is not a viable economic option to 3D print bus components. Thank you for watching the video.